So continuing with 6.3, this example 2 will go through the exact same stuff we did in the first set of examples. You can treat it as a DIY and pause the video right now and go through the work yourself. Otherwise, I'll walk you through it now. If we graph the vector v represented by the directed line segment with initial point at negative 2, 3, so negative 2, 3 is here, negative 7, 9. Somewhere like that. So that's what that drawing would look like. Now it says find the component form. Again, there are two ways to do this. You can manually move your vector so that this initial point ends up at 0, 0. So you can do that, which would be to go down 1, 2, 3, over to the right 2. So if you go down to the right, down 3, right 2, so that means I have to go down 3 to the right, 1, 2, 3, 1, 2. It's about right there. Or we can go ahead now and do vector v and do terminal minus the initial. So terminal would be negative 7 minus negative 2 and 9 minus 3. So if I do this, I'm getting negative 7 plus now, so that's negative 5 and 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and it worked. To find the magnitude of the vector, because it's in component form now, I don't have to say minus 0. So I don't have to take the negative 5 minus 0 each time. I can just take the square root of negative 5 squared plus 6 squared. That's 25 and 36. So I'm getting the square root of 61. And then they ask us to find a unit vector. And a unit vector is simply to take your vector, which is negative 5, 6, and put it over your magnitude. So then you have negative 5 over the square root of 61 and 6 over the square root of 61. And we really should do our rationalizing trick. Multiply the top and bottom by the square root of 61. And so you really end up with negative 5 square root of 61 over 61 and 6 root 61 over 61. Now, if my vector is negative 5, 6, I can switch to what is called the linear combination just by putting in I and j. So I can do the horizontal component with the I and add to it the vertical component with the j. That's what linear combination means. All right, so then the last one is to find the direction of the vector. So I would draw an xy axis. I'm going to draw my vector again. That's negative 5, 6. And so what that does, let's do a different color. What that does is creates the right triangle that we've been working with since chapter 4. So I can do tangent of theta. Theta would sit right there. Tangent of theta is opposite 6 over adjacent negative 5. So to do this, we'd go to our calculator, clear that out. We're going to do inverse tangent of the 6 divided by negative 5. Yeah, I get negative 50. Let's just call it negative 50.2. But my vector is in quadrant 2. So it's pointing all the way over there. Clearly negative 50 degrees is not there. I have to be between 90 and 180. So we have to use the idea of reference angles. And so when I look at this angle, I can take 180 minus 50.2. Now I'm not subtracting it because it's negative. I'm just saying this is 50 degrees. So we should be right around 130 and 129.8 degrees. Okay, so this is the mixed practice. I'll just go through these problems again. If you want to pause it and do them as DIYs, go right ahead. Otherwise, I'll start. The first one is find a unit vector in the direction of. So the first thing you'd have to do is find the magnitude, which would be the square root of negative 2 squared plus 5 squared. So I end up with the square root of 29. And then when I find the unit vector, I can take the negative 2 over the square root of 29 and the 5 over the square root of 29. And I should clean that up by rationalizing both. So that would be negative 2 root 29 over 29 and 5 root 29 over 29. The second one is let u be the vector with initial point 2, negative 5, and terminal point. Write u as a linear combination of the standard unit vector. So to do this one, I first would find the component form for vector u. So I'm going to do the terminal negative 1 minus the initial 2. And I go back to the terminal and I grab the 3. And now I subtract the negative 5. And so I end up with, again, the angled brackets indicate component form. So this is negative 3 and 8. So then if I wrote it as a linear combination, I do negative 3i plus 8j. All right, so number 3, to find the direction of this vector, I can just take it in its linear combination form and know that it's a vector that's going to the right 3 and up 3. So this is the vector right here. So I can set it up as the tangent of theta equals opposite 3 over adjacent 3. And when is tangent 1 in the first quadrant? Well, that's at 45 degrees. You can go to the calculator and type it in if you want to get the angle, but it's 45 degrees. But that was understanding that linear combination, just 3 to the right and 3 up. Same thing down here. Now this one is a little bit different, so we have to, we're going left. And that's a crazy number there, but that's up because it's negative and positive there. So we're going to go to the left and up. And so I go left, negative 4, and I go up, forward 3. So again, I can do my tangent to find theta. The tangent of theta is opposite 4 root 3 over negative 4. So what this is really asking is when is the tangent negative root 3? Well, that happens at the 60-degree angle. And so my theta then, this whole thing right here, would be 120 degrees. You can also go to your calculator to find that. So remember, we were doing inverse tangent of negative square root of 3. And so that would be negative 60 degrees, and that can't be in the second quadrant. You have to have an answer between 90 and 180, and that's why we came up with the 120.